going to explain the topic of multiplicative inverse of a matrix. So before moving towards multiplicative inverse of a matrix, we should know that what is determinant of 2 by 2 matrix and what is an adjoint of matrix. Also we should know about singular and non-singular matrix. So first of all, let's move on towards determinant of a 2 by 2 matrix. Determinant of a matrix is denoted by det A, or it can also be denoted by writing A enclosed in two straight lines. Let's see an example of determinant of a matrix. How to find a determinant of a matrix. So let's suppose A is a 2 by 2 square matrix with entries of 1, 2, 3, 4. So to find its determinant, that A, we will multiply its entries, diagonal entries and also the non-diagonal entries. Like this, we will multiply 4 with 1 and 3 with 2, like this, and put a minus sign between them. Let's see, 4 multiplied by 1 is equal to 4, minus 3 2's are 6. How we get that? We get by multiplying 4 with 1 and 3 with 2 and putting a minus sign between them. So that's it. When we will subtract it, we will find the determinant of A, which will be equal to minus 2. Okay, hope so that should be clear to you. So let's move on towards singular and non-singular matrix. A square matrix A is called singular if determinant of A is equal to 0. Let's see an example. Let's suppose this is another matrix M with entries 1, 2, 1, 2. Okay, so when to find out that whether it is singular or non-singular, we have to find its determinant. Let's find out it. Multiply 2 with 1 equal to 2, minus 2 multiplied by 1 is equal to 2. So 2 minus 2 is equal to 0. We just multiplied these two diagonals and non-diagonal entries and subtract them. So we found that answer is its determinant is 0. So if its determinant is 0, it is a singular matrix. It is singular. So what is so hope so that singular matrix should be clear. So what is non-singular matrix? The opposite of it is opposite of singular matrix, like this. If the determinant is equal to 0, it is singular, and if it is not equal to 0, it is non-singular, like shown in this example. In this example, the determinant of A is equal to minus 2, so it is non-singular. That's it. So let's move on. What is adjoint of a matrix? An adjoint of a square matrix is obtained by interchanging the diagonal entries and changing the sign of other entries. Let's see how we can find an adjoint of a matrix. Let's suppose B is a matrix with entries 1, 2, 5, 7. It is matrix B, so its adjoint we can find its adjoint by interchanging its diagonal entries. You know that diagonal entries are these are diagonal entries. We have to interchange them, means there will come 7 and 1, and changing the signs of other entries means non-diagonal entries. So we will change the signs of these non-diagonal entries and it will come -2 and -1. This is adjoint of matrix B. So just easy, very easy. Just need a bit practice to remember this concept. So let's move on towards multiplicative inverse of a non-singular matrix. How to find multiplicative inverse of a non-singular matrix? For the first, let's suppose that A and B are two non-singular matrices of same order. Then A and B are said to be multiplicative inverse of each other if A multiplied by B is equal to B multiplied by A is equal to identity matrix. Inverse of A is denoted by A inverse written as A small -1 at its exponential place. So A inverse will be equal to A multiplied by A inverse is equal to A inverse multiplied by A is equal to identity matrix. So inverse of a matrix is only possible if the matrix is non-singular, means its determinant is not equal to 0. So how to find an inverse of a matrix using adjoint? Let's see. Let me show how to find an inverse of a matrix using adjoint. The formula for inverse of a matrix is adjoint of A over determinant of A. This is formula for finding the inverse of A. So let's find out. Let's suppose that A is equal to 1, 2, 5 and 7. This is A, and to find its inverse, first we have to find its adjoint and its determinant. So let's find out its determinant. Its determinant is equal to 7 ones are 7 and 5 twos are 10. 7 minus 10 is equal to -3. 7 minus 10 is equal to -3. Its determinant of A and adjoint of A is 7, 1, -2 and -5. This is its adjoint. So we figure out that the matrix is non-singular as its determinant is not equal to 0, so its inverse is possible. So we will apply the formula. A inverse is equal to adjoint of A, which is this 7 -2 -5 and 1 over determinant of A, which is -3. So we can also simplify it as -1 over 3 multiplied by 7 -2 -5 and 1. So after multiplying that, we will find this matrix -7 over 3 2 over 3 5 over 3 and 1 -1 over 3. So this is the inverse of this matrix A. To prove that they are inverse, using this statement we can prove that a matrix is multiplicative inverse of another matrix or not. Means when we will find inverse of matrix A and multiply A with its inverse, we will get an identity matrix. And if we do not get an identity matrix, this means that they are not multiplicative inverse of each other. There is some mistake in finding the inverse. So let's see how we can prove two matrices are multiplicative inverse. This is matrix A and this is its inverse, A inverse that I have found. And when we will multiply them both, we will get an identity matrix, so we know that it is an identity. They are multiplicative inverse of each other. So how to multiply matrix I have told in my previous lesson. You can watch it on my channels. So let's move on towards next topic, which is verification of AB whole inverse and that is equal to B inverse A inverse. So simply there are two matrices A and B. We will first solve the left hand side to verify this statement, this law. So on left hand side, first we have to multiply both matrices A and B and then take its inverse. We will multiply the both matrices and answer will this. Then we will find inverse of this matrix, means AB whole inverse, and its determinant is 3. Then we will find its adjoint and multiply it, divide it with its determinant. So this is the answer. Then we will solve the right hand side, B inverse multiplied by A inverse. We will multiply these two matrices after taking their inverse. So first we will take inverse of matrix B and matrix A, find their adjoint and determinant, and by using the formula that I have told before, we can find their inverses and then multiply them both, and after multiplication we will get the same answer which was of right hand side. So the law of AB whole inverse is equal to B inverse A inverse is verified. So this was all for this lesson. Hope you have understood all the concepts. So please like the video and thanks for watching.
Nice video. Now I am leaving. Hey, you haven't subscribed yet? Not now.